Deep in caves in eastern Mexico lives a fish with some remarkable features. They have no eyes but can get around fine. They're obese but with no health problems. They're old but not elderly, and they're entirely unique but not their own species. Is your initial reaction to all of that confusion? Disbelief? Curiosity? If you have questions about these fish, then you're already most of the way to thinking like a scientist. As I tell you more about the fish, see if you can predict some of the questions that real scientists asked about them. These questions can range from the simple, why does that thing look the way it does, to the wide-reaching, how can knowing more about this affect our world at large? Before we talk about the fish, though, what makes these questions so important anyway? The truth is, for all of the work we humans have put into figuring out the world, there are still way more questions than answers. There's just so much of the world we don't know a lot about. For example, about 95% of the ocean floor has not been explored. It's been estimated that over 86% of animals have not even been discovered yet. And of all of the deadly diseases in the world, only 2 have been completely eradicated. There's so much to learn and to do that we need all hands on deck solving these mysteries. More curious people like you thinking like scientists leads to more perspectives, which lead to more discoveries and more understanding of our beautiful world. That's why I'm talking to you about the fish. Imagine a small silvery fish only a few inches long. These fish swim together in groups, can be pretty aggressive to one another, and they eat a number of small animals like worms and insects. If you tried to pick one of these fish up, it would dart away before you even got close. This is the typical form of the species Osteonyx mexicanus, also known as the Mexican tetra. These fish live in rivers, mostly in the Sierra del Abra region in the mid-eastern part of Mexico. If you were in Mexico 1,000,000 years ago, that would be the only version of this fish species you would find. Now, you've probably seen tons of fish that look the same as what I've described, but these fish are special. They're relatives of the eyeless cavefish. In the fish's river habitat, there are seasonal rainstorms that overflow the rivers, making the water spill over the banks. Thousands of years ago, these floods swept some river fish into caves that exist next to the river. Suddenly, the fish went from a sunny and open stream environment to a pitch black cave environment. Now imagine that small silvery fish from before, trapped in a newly formed cave pool, with no light, barely any food, and no way to get back to the surface. All odds are against this fish surviving. However, the fish did not die. As repeated river floods over thousands of years brought more fish into the caves, they evolved into the cavefish we see today. The fish had to change a lot to thrive in the caves. The fish's pigment decreased, removing their silver color, and you couldn't see it anyway deep in the caves. They became fatter, making sure to store the rare food that they can get from bat droppings and other cave animals. And they became less aggressive, which makes sense since bothering your neighbor's probably not a good idea when you're permanently stuck together in the caves. The most notable change is that the fish's eyes completely disappeared. This process didn't happen in just one cave. It happened in a similar way in all of the caves across the region that the fish fell into. Now you probably have many more questions or maybe even possible explanations. Let's take eye loss as an example. Why would the fish not have eyes in the caves? You might say, well, duh, there's no reason for eyes when there's no light to see anything. If that's what you're thinking, then congratulations. You've come to the same conclusion as Charles Darwin, who discovered evolution. How's that for thinking like a scientist? Darwin saw that cave animals often don't have eyes, and he thought that this must be because of disuse. In other words, there's no benefit for the fish to have eyes, so fish born with worse eyes survive just as well as the ones with good eyes. Over time, the eyes disappeared because there's just no need for them. Now, this is good intuition, but what if I told you that Darwin was wrong? Can you think of another reason the eyes may have disappeared? One possibility that researchers came up with is that having eyes actually comes with a cost. When you're really hungry, don't you sometimes just want to close your eyes and rest? It's the same principle, just on a larger scale. Scientists tested how much energy the river fish's eyes, and the part of the brain that interprets vision, use at rest. They compared that to the energy used by the brain of the cavefish without eyes. They found that the fish with eyes used up to 15% of their available energy for seeing. As a comparison, we humans only use 7% of our resting energy to keep our entire heart working. That's a lot of energy the cavefish are saving by not having sight. A fish in a cave that's born without eyes shouldn't survive just as well as the fish with eyes. It should survive even better since it doesn't have to waste so much energy. This process of coming up with questions, thinking about possible explanations, testing them, and then refining those explanations based on the evidence is the core of scientific thought. This can be put into practice for any interesting thing you might observe in nature. Now, the fish having no eyes is easy to see just by taking a quick look at the fish, but many interesting quirks of animals can only be seen through comparisons. For instance, when you put a cavefish and a riverfish next to each other, you'd see that the cavefish are much fatter than the riverfish. Now, that's strange, you might say. The cavefish don't seem to have any health problems tied to obesity. Scientists have actually tested this, and it's true. There really aren't any negative fat-related health issues for the cavefish. However, if you found a fat riverfish, it actually would show signs of the fish equivalent of diabetes or fatty liver disease. We know that obese people are often less healthy than non-obese people, so why wouldn't it be the same for the cavefish? Another thing you might notice is that older cavefish don't show signs of aging. Old riverfish, like most animals, including humans, have problems as they get old. They get a hunched back, their fins become tattered, their skin becomes wrinkly and sunken, and they slow down. But this just doesn't seem to happen to the cavefish. They get bigger as they get older, sure, but they don't become elderly in the same way. Even after 15 years, when the surface fish are often barely still able to swim, the cavefish look the same as they did when they were in their youth. Now, how is that possible? And how would you even begin to try and figure it out? Luckily, observation can provide a starting point for questions like those. The cavefish and the riverfish usually don't meet in the wild, but scientists put some together to see what would happen. In some cases, the riverfish would be aggressive and attack the cavefish, but in other cases, something spectacular happened. The fish would have children. Now, this is the magic of the cavefish and the riverfish. They are so different, but can still have children together, so scientists can see what their children look like and investigate their characteristics. For example, the children of cavefish and riverfish are not all blind, nor all sighted. They have a mix of various eye sizes. In this way, scientists can both think about why something is the way it is and think about how it works. Scientists have used this method of looking at the children of cave and riverfish to investigate all sorts of things, like the cavefish being fat without health problems, aging without being elderly, and being eyeless but still very aware of their surroundings. This research has led to discoveries that could even be helpful for humans with diabetes, aging, or blindness, such as identifying specific changes in the cavefish that make them more or less susceptible to these issues. There are many studies on these topics going on right now all over the world, progressing our knowledge even further. While it's true that these advances in human health and general knowledge are the product of intricate equipment, complex processes, and trained professionals, the core ideas are never so complicated. These fundamental ideas are much more accessible than you might think. Every single one of these breakthroughs has started with somebody hearing facts, like you just did about the cavefish, and asking a question about them. And even if fish aren't your thing, think about the next animal you see. What's unique about that animal? What could we learn about it? What comparisons can you make? You don't have to be a scientist to think like one. Maybe you'll ask something no one has asked before, and we'll learn a bit more about our mysterious and fascinating world from your insight. So next time you see an animal, why don't you challenge yourself to come up with 3 questions about it?